Hi, I'm Tom and I talk about code. Welcome to today's show where we're going to be doing math. We're going to be getting back into vector and matrix math. I haven't done this for quite a while, but we are going to be doing it primarily through Lua APIs. So today we're going to be building those APIs. One of the big problems when I was trying to do 3D before is it was really slow to iterate. When I wanted to try a different transform matrix or something, I had to go into the C code, I had to recompile things. Hopefully with Lua, I can have a much tighter iteration loop and eventually, potentially even, connect to the running program on the PlayStation 2, play around with the matrices mid-frame. That's something I'm going to play around with off camera, but for now we're going to build some solid math APIs that are going to allow us to experiment much better and allow us to do much better things even in the 2D space. Things like rotation, things like taking the angle between two vectors or the distance between two vectors, things that we're going to need if we actually want to build games. So let's get into it. We have a little plan here that I've been drawing up, okay? So there are a few things we're going to do. So the goal of this stream is to build primarily C APIs, but then Lua bindings for them as well, for vector 2, vector 3, and a 3x3 matrix. These are going to be really fundamental for us here, right? If we want to do 3D stuff, we're going to need a 4x4 matrix as well. We're going to start with a 3x3 matrix and live in 2D rotation land for now. But yeah, we'll get there. We'll get there when we get to it. And then we're going to write some Lua wrappers to make the APIs a bit nicer. So our APIs are going to be very raw. We're going to do a lot of the work in C and just expose them to Lua. A lot of the Lua world is going to kind of be like pipelining C functions together into transformations. But eventually it would be nice if we could, for example, get the X of a vector as well. The way we're going to do this is going to be very C focused, but then we're going to go in and give it a nice Lua front end too. The first thing we need to look at is how we actually access data in a buffer. Now, I think I actually started this, by the way. I started this with a file called mathlua.c, right? And this is what this is going to look like. This is what this is going to taste like. So rather than starting this from scratch, right, I kind of did some experimentation off camera. And so if we create a vector 2, okay, so this is the C function that's going to create a vector 2 that we're going to bind into Lua. The first argument is a buffer, and I should write this down. So new vec2, right, takes a buffer, it takes an X, and it takes a Y. And then what this function is going to do is it's going to go into our buffer, it's going to say buff 0 equals X, buff 1 equals Y. And this idea is going to be the fundamental thing that powers our entire math API, right? The idea that we just have buffers underneath, but then we're providing Lua interfaces to them. And on the C end when we implement these things, we're just going to be dealing with buffers. And in this case, because this is vec2f, this is actually going to be treating the buffer as an array of floats. So that's exactly what we do here, right? We get the pointer to the buffer, right, the head of the buffer, and we get the size of the buffer. We grab the X and the Y from arguments, right? So in this case, argument 1 is going to be our buffer. We just dereference some fields from it like we've been doing all along. Grab X and Y as arguments. We make sure that we have enough room in our buffer to support 2 floats, right? 2 floats. And then we set, like I was doing here, right? Buffer 0 is X, buffer 1 is Y, except we do it through this float view. And we could do this without creating a new variable. We could say float ptr 0 equals X, I think. I think that would resolve this first. Because it could either bracket it like this or it could bracket it like this. And I'm pretty sure it brackets it like that. And actually, let's do this. I think this is a bit nicer, right? We're going to write this a few times. But let's do this for now. Let's do this for now. And then we return... What do we return? We return... What do we return? We don't return the buffer. What we actually need is a new object. We need a new object on the Lua heap. A new vector object, right? This vector object is going to be quite a simple object. So... It's going to look, let's use curly braces to show the object, right? It's going to have one field. The one field is going to be a reference to this buffer, right? And we're going to know that its type is going to be, it's going to be like an m.vec2 or something. So it's going to have a meta table that tells us how to do some stuff with it. And that's it. That's the whole table. So let's do this. Let's go Lua new table I think that's the function. Let's check over in another new create table. Create table. And it's going to have one named field. Lua push string L buff Lua set field, I think it is. I forget these APIs every time. Set field, there it is. L -1, it's the first argument, no, the second argument on the stack, sorry, and we're going to set this to, what are we setting this to? We need to get argument 1. How do we get a Lua table off of the stack? Sorry, and as always, I want to show off the Melbourne skyline as I go, but we'll talk about that a bit later. Lua C APIs. So, what have we got? This isn't what I want. Where is it? There's a page. There's a page on the lua.org site that has the entire C API. And I can never find it. I can never remember the URL for it. Documentation. It must be in documentation, right? The reference manual. Here we go. Lua functions. Okay, so this is the Lua reference manual. Taking documentation. Hold on, the reference manual which describes the syntax. Okay, well let's look at 5.3. Let's go Lua to... Oh, hold on. The C API is listed here. Don't mind me. So, can we grab to pointer to number to... Sorry, I'm getting a phone call. I'm going to have to BRB already, unfortunately. Okay, so our goal is to pass some data through, right? So we've got this argument 1 on the stack. We need to pass it through as this field in the table, but I don't know how to do that with a Lua object, right? It's not a user data. To C function, no. It's not a string, it's not a number, it's not a, is it a pointer? Is it a pointer? Is it a pointer? Converts the value of the given index, going to use user data, a table to table. How do we Lua pop table? Well, maybe let's see push Weird. Push our string. How do we do this? Push no, not a global. Push f string, push c function, push integer, push let user data, push literal, push string, number, pthread, thread represented by L, push value. I don't know. Cool. Okay. Cool. Push table. How do we push a table onto the Lua stack? How do we do it? Push string, set table. No, but how do we push a table into a table? Set field table nested. Well, this is a weirdly simple thing that I just can't work out how to do with the C API. I didn't realize this was gonna be what caught me up. String set field. Oh wait, hold on. What? I'm going crazy here. Right? Because we push a value. I'm going crazy. Okay. So we push a value onto the stack. We push a string. So what I really want is to. Push a copy. So what I want is to push element number 1, right? Lua push. What is it? Push value. L, we want to push value 1 to the top of the stack. The first argument, we want to put it on top of the stack. We push a string to the stack, and then we just set the table. It pops the first 2 things off of the stack. We need to give it an, oh, hold on. No. And then we give it, yeah. Here we go. Okay. I'm going crazy. I'm mixing up my my set and my get. So we've created a table. It has one field called buff, and that's all we need. So then if we have static int lua vec2 add vec2, let's do it like this. Lua state L So let's imagine an add function. What do we need in an add? So let's go vec to add. Right. Well, we're going to have two arguments. We're going to have a vector, and we're going to have a vector. So what we need is, I guess we need to consider, does this add in place or does this create a new vector? Oh, we've got a question coming in chat. Under question. Nice. Colt Zero says hello. You switched from Windows 10 to Ubuntu almost a full year ago now, and you're still struggling with some things. Near Automata on Linux for the first time earlier this week. None of the wine installs could already run it. Let's pull chat over just for a sec. Man, yeah, gaming on Linux, right? I game a lot less now that I'm just on Linux, and I don't think that's a bad thing. I'm working in C at the moment. I'm doing C bindings into Lua. I might do some PlayStation 2 assembly if I feel, excited enough to make this vector stuff a bit faster. I might try that out. Refraction PCA62, good morning. Welcome to the math show, the show where I do bad math. It's going to be great. The big question right now, okay, if we add two vectors together, right, do we do it in place or do we create a new vector to add them into? I think we need to have an add in place function, and then we need a function that creates a new vector. So I guess you can think of the add in place, you can think of the add with creating a new vector. So let's say we have v2 add star, which is in place, and then v2 add, which creates a new vector, right? So let's go a, b. So this adds in place, and so it gives us back a, which has been modified. And then we have this one a, b, which gives us back c, but we can really just say c equals copy a, and then cool, v2 add star c b, right? It's actually not hard to, so this is the one we want because it's more general. You can do more things. Near, because you learned how to mod it, you want to dabble in modding again. That sounds like fun. I love modding old games. I would love to pull some PlayStation 2 games apart now that I've kind of learned out how the hardware works and try and mod them. Bad math is awesome. You're taking linear algebra. This is perfect. I love it. Is that like basic linear algebra, like first year uni stuff? Or they were some fun courses in my degree. I was very good at them, but oh boy, they were hard. Oh boy, they were hard. Some of the most stressful exams I ever had, right? Because there was just a lot in those courses. So let's do this. Let's do it this way. Let's go add v2. We want to grab Lua push string. We're going to grab the pointer from the first argument, and we'll grab it as a float. Buff1 equals Lua2 user data. Right, so we're just saying this is something that Lua doesn't own. And then we're going to do the same thing again. Yeah, cool. We'll grab it from the second table, and this is going to be our buff2. And then we're going to say buff1 0 plus equals buff2 0, buff1 1 plus equals buff2 1. Confusingly, we have one indexed the variable names, yet the arrays are 0 indexed. I love it. Here's a comparative newer game, PS4 era. You did get the game running, that's good. Different wine manager. All the wine manager stuff is so confusing. I still haven't really worked it out. I still haven't really figured out a good way to do it. But it's awesome if you've worked it out. And then do we just return 0 in this case? It modifies it, so yeah, let's say return 0, right? So as far as the C API is concerned, all we do is modify in place, but then we can implement, this other behavior that creates a copy. We can implement that in Lua, right? We can just have the simplest possible behind the scenes, the behind the scenes stuff happen in C, and then write more expressive, APIs in Lua. So in Lua copy vec2. We need this copy function as well. Is the Lua state all of the data you're working with at any moment? I don't know exactly what goes in Lua state. This is a Lua defined thing. It's a little bit magic. The main way we interact with the Lua state is through the Lua stack. And this is part of the reason Lua is so cool, part of the reason it's so easy to work with, okay? When we have, so I'll talk it through a little bit more carefully for this function, right? But so if we have this Lua state come in, so I guess, hold on, I need to think a little bit about what this copy function looks like. So let's say we have, let's draw it out. v2 copy, right? We're going to say we copy, yeah, let's say we copy from a vector to a vector. They're both vector objects, right? So both these vector objects are going to have a buffer field, right? And then we just do the copy from A to B, from B to A. Which direction should copy go? From to from. Anyway, we have two vectors that get passed in to this function when it's called, so they're going to be on top of the Lua stack, which means that the Lua stack works. So this is like the head of the stack. The first thing on the stack is at position -1, so the stack head's at 0. The second thing on the stack is at position -2, -3, blah blah blah. And then your function arguments are kind of in the stack frame underneath, right? And they're at positions 1 for argument 1, 2 for argument 2, 3 for argument 3, etc. So in this case, we're going to have something in argument 1 that we want to grab out and something in argument 2 that we want to grab out. And that's exactly what we're going to do. But to use this getTable function, we actually put something on top of the stack, right? So we push a string, this field that we're dereferencing, because this is actually a table, right? It's like a JavaScript object or whatever. We push a string. So getTable takes the thing from the top of the stack as a name, and then it takes whatever index we give it, in this case index 1, the first argument to the function. It uses this to dereference something from this, and then this gives us back our pointer, or whatever data we want. So I guess there are a few steps to that, and that probably wasn't the best explanation. But the idea is that the Lua state makes it very easy to just deal with this data by index, by number. We don't have to deal with more complicated structures than that. Or if we do it by string names, which has pros and cons. It isn't the fastest, but it works very, very well. So actually, this is going to be exactly the same here. So let's just copy it. Let's copy the whole function, because it's going to be basically the same thing. Cool. So we get the 2 pointers, except here we say, so I guess copy to from. The thing on the left you're copying to. I think this is a more, right, because if you look at, for example, I don't think I have these man pages installed. I really should. I really should. If we look at string copy, destination source, right, to from. We're going to stick to that style. So this is enough that we can bind into. Cool. Unity Engine PC game. Lua C# integration called Moonsharp. Moonsharp was put in by the developer. Nice. That's cool though. That must make it easier. And part of the reason I'm using Lua is it's very easy to hack on. It's very flexible and easy to extend. You can do all kinds of cool things with it. So hopefully, building these APIs well will mean that people can take games that I write or, code that I write and extend them in fun ways. I want people to take the games that I build and remix them and do fun things and just create lots of cool content for the PS2. Is there memory management in Lua? Lua is a garbage collected language. So you do things, things like push string, right? Creates a string, maybe has to put that string into the Lua heap somewhere. You make a new table, Lua just does it. And it will garbage collect itself. Most used for simple commands in the game. Then before you know it, 2,000 lines of Lua. Lua's not the most succinct language, right? It does tend to get wordy, especially if you're doing lots of metatable stuff. I find just the setup for it takes a lot of lines, right? But very, very good for just expressing a lot of logic simply. Here's another good question, okay? If you call a copy function, right? Do you expect this to return a value? I mean, I've also written this with different semantics here, but anyway. Should copy return the thing that you're copying to? Should add return, like an in-place add, should this return the actual value or should it return nothing? Because it's not hard to do. We can just go Lua push value and we can tell it to push the thing in the first position of the stack back, to the top of the stack, and then we return it. A deep copy? No, in this case, this is a very, this is a deep copy, I guess. It's like, but there's only 2 values to copy, so it's not really We don't really get into that. There's no nesting here, so deep versus shallow copy doesn't apply. It's a copy by value. Oh, Strager rated with a party of 44. Holy crap. It's code. I know, it's crazy. What is going on? Zebrow, welcome. Thank you very much for the message. The current question, okay? 44 new people to have opinions, okay? I'm keen for your opinions. Good morning, good morning. I need some opinions. Okay, so we're writing Lua APIs for math, and then we're actually doing the math in C, and it's going to be very like, linear array buffers. We're going to hide all the magic behind Lua, but the most important question on my mind right now, okay? If you have a function, let's say, you call copy to from, should you be able to, do you want this to return a value, or should this not return a value, right? Should we get something back from this, or should it not? What are we doing this for? Why are we doing this? We're building a game for the PlayStation 2. And I did this before I got the 3D math going. I got some basic 3D stuff happening, and it was really tedious and it was really fiddly. So I'm slowly building up Lua APIs to control the hardware and also to do some cool things like maths. So, I want to be able to iterate faster because like rebuilding your code, redeploying it to a PlayStation 2 is slow. My goal is to have nice Lua APIs that mean I can hopefully iterate faster. And then the goal is to be able to reload Lua scripts dynamically. Like, have the PlayStation 2 listen to a port, send it a new script to run, it'll just do it. The reality of that is a little bit more complicated, and there's a lot to realize before that. But for now, let's just build a really solid math API, and no return. I see no other opinion, so I'm going to go with this. I'm very easily influenced. Return 0. When you do these kind of Lua bindings, right? The value you return from this function is the number of things that Lua expects you to have left on the stack as return values. So we're going to make a function Lua init math. This is what we're going to call when we first start up our program. It's going to take in our nude Lua state, and it's going to define these functions. So Lua create table. We need to make a new table that has all of our cool new math functions in it. Zymus agrees with no returns. Awesome. I like it. Probably just makes usage more confusing. Yeah, true. And we're going to wrap these up in Lua anyway, so we can change the semantics in Lua, right? We could have copy not actually take an argument in Lua and just create something on the Lua heap. But for now, like the C versions, I want to be very simple. So we're going to create a table, Lua push C function, Lua new vec2. Okay, so we push our C function, and then we give it a name. Set field, set table. I can never remember what this is called. Set field, L, new vec2. So we're going to give these bad names, right? If you're looking at this and you're stressed out because these names don't quite feel right for Lua style, don't worry. We're going to do a Lua wrapper to this that's a bit nicer. Push C function. But we're going to do it on the Lua side. Lua copy vec2. Lua set field. Perfect. Is this Vi? This is NeoVim. This is Vi like it's 2022. Okay. I do want to try PS1 or PS2 homebrew. Your head just isn't there right now. One thing you want to do is see if you can make a PS1 homebrew game run off of a memory card instead of a disc. That's interesting. You can load things off of memory cards on the PlayStation 2. I think the exploit's called Tony Hacks. I don't know, because like the PlayStation 1 memory cards are extremely limited. They're very, very simple. So yeah, that would be cool. That would be really interesting. At the very least, you could have a loader, like an elf get executed that then loads more data off of a memory card. I would be really interested to see what you could do with that. That's a cool idea. Zebrow, did I call you out for the follow, by the way? Thank you. I appreciate it a lot. Lua set global. So then we want to give this cool new table we've created a name in the global scope, and that name is going to be M. Okay, M for math. This is important. I guess we could also call it something longer and then alias it in our like includes. Let's do that. Math C lib. Let's give it a longer name and we'll alias it. Cool. And then we return 0. We need to include some headers. I think that's the only header we need to include. Everything else, we're just doing raw buffer manipulation. Eventually, we're going to have to do some meta table stuff as well, but we'll get there. We will get there. So what happens if I just try and build this right now? What's going to happen? What's going to happen? I need to... Oh no. This file is such a mess, okay? So we've got this script header which defines all of the kind of script entry points, I guess. So for example, draw Lua. When we call this function, it defines all of our drawing functions into our Lua scope. So we have gs_lua_init, okay? We have lua_tga_init. We have lua_init_math. We now have a third style. Oh, this is a disaster. Let's rename this. So we want math lua init. And this is actually better. Functions that start with the name Lua underscore are actually kind of, I don't think reserved, but they are standard Lua functions, right? We don't want to step on Lua's toes. We want to keep out of the way of Lua. So let's see what happens if we do this. If we go into main.c, if we go into init, where are all our inits? Where are they? Math Lua init. And then we just need to add it to our make file. Lua obj math lua.o, and let's see what happens when we build. I know what's going to happen when we build. It's going to say we're not running Docker. Okay. And now we're going to build, and we get some errors, but that's good. That's good. This is defined but not used. So this means that we've done something wrong. Lua new vec2. Lua new vec2. This says this is defined but not used, but I clearly see it being used. So does this mean that there's a serious syntax error before this? Potentially. Okay, so this actually did not work like I thought it would. Ladka8 says, sorry, but you hate Lua. That's, it's understandable, right? I understand hating Lua, but if you need a simple, no batteries included language that you can just drop into any context, like one of the cool things about this is that I'm able to, drop this in. I can just have a raw buffer API and a few very simple APIs for sending buffers to other hardware components on the PlayStation 2, and I can build up from there. So for example, if I look at draw2d.lua, this is the worst thing I have ever done, but it's also kind of beautiful. If we look, like this is describing how to fill an arbitrary buffer with arbitrary data. So things like text A, right? This is a register in the PlayStation 2 graphics synthesizer. And I can just do some really dumb stuff. Let's go GIF. We make GIF tags. We just push a bunch of arbitrary integers into a buffer. We push floats into a buffer. We're just putting numbers into a dumb buffer. And it's really, really painless. And it's really, I guess, doing this stuff in C is fiddly. We can do it in Lua. We can have a little bit more overhead. We can have like a few abstractions that make it a bit nicer, and suddenly we're just doing things in a better way. Okay, so there are two ways that the C compiler can decide to dereference this. I thought it was going to do this. I think it has actually done this. I think. I'm not totally sure. I thought it was going to say get the 0th index of pointer as a float. So what we're going to do instead, we're going to come in here and we're going to say this is just a float. We're going to cast it. And then we're going to go through everywhere else we've done. Well, everywhere else we've done this properly. That's good. That's good. That is good. So Lua push retards 2 arguments, but only one given. Yes, that checks out. That checks out. We need to give this the Lua state as well. Every Lua function takes the Lua state as a first argument. If you're used to object-oriented programming, you're familiar with this pattern. Here, because this is C, the if is just explicit. New vec2 control reaches the end of a non-void function. This is actually important because if we let this control flow through, Lua may just get some garbage, or it'll probably get some garbage, and it won't know how many things should be on the stack. The stack will get crazy. It'll look at, invalid memory. So if I run this now, it starts up and it runs, and my texture example is happy, right? There's no error in startup that I can see. Everything looks okay. Everything looks okay. So let's go, let's make a file called script math.lua. Okay. Do I work as a software engineer? Yes, I am a programmer. I work at a big finance institution in Australia. I smash Golang code for a job. Cool, so math.lua. Okay, and now we're going to build a slightly higher level API for this, right? So if we come into our goals, we've done half of this. This is like, we can cross out the first half of vec2f. So let's go local v2. Let's say our vector2 is just, let's go buff equals, well, it's going to default to nil anyway. Let's do this. Let's do this. And you made a PlayStation 1 homebrew game, by the way. That's really cool. That's really cool. If you have source for that, I would love to see it. You've been programming for years but never had an actual job, just a hobby. That's a cool way to do it. I like it. Did I have to do a lot of leak code? I had to do 0 leak code in my interview. Once I got into an interview, they absolutely loved me and I got the job. I went in through a grad program though, so that was a bit different. Man. Yeah, no, I was a hobby programmer for years, right? I've been programming since I was about 9 years old. Been doing it a while. Ladka8, thank you for the follow. I appreciate it. Glad you are enjoying the show. Awesome. So we've got our vector2, right? Let's function v2. We're gonna have a new function. It's gonna take an x. It's gonna take a y. Now this is gonna have to do something gross, okay? Because we're gonna need a new buffer, and to get a new buffer, we're gonna have to call a resource manager function. We're gonna have to call resource manager alloc. Floats are 4 bytes. We need 2 floats, and then we're gonna call is Golang harder than, say, JavaScript? Golang is easier than JavaScript in lots of ways and harder than JavaScript in some ways. Golang's very opinionated. It's a very simple language. You know, it's got a very clear idea about what it wants you to be able to do and how you're going to be able to do it. JavaScript is the wild, wild west. There's a million ways to do everything. There's a million edge cases. There are lots of foot guns. Golang, I find easier to write safe, you know, secure code that I'm very confident in. The Go standard testing facilities are really good, right? Like testing is just built into the language ecosystem. So if I was writing solid enterprise software that, you know, dealt with people's money, I would go with Golang or Haskell, but probably Golang first. Honestly, not sure how good of a programmer you are. Look, I mean, being a good programmer or not, like there's a million ways people want to measure this. If you can achieve what you want to achieve, and if you can, like, you know, still continue to learn, that's what matters, right? If you're building cool stuff and you're excited by it, that's what matters. Don't worry about how good or bad of a programmer you are. There's a lot of like arbitrary dick measuring that really doesn't achieve anything in the programming world. Migrating to Golang from Java, they use a lot of programming languages. My first job was with Java in that organization though. So I've gone from doing a certain thing in Java to now doing a very similar thing on a different team in Golang. Like, go figure. Maybe the writing is on the wall for the future of the Java developers there, but I don't know. So we create a buffer, right? We allocate it on the stack, on our heap, sorry, in our C heap, right? So these rmalloc functions do C allocations. Now, eventually, I want to be able to have a function that's going to do a Lua alloc, that's going to allocate arbitrary data on our Lua heap, that's going to be garbage collected and whatnot. For now, that is not what we're doing. It's going to take like 2 seconds to do. I just need to actually sit down and do it, right? So math Lua, we're going to call new vec2. We're going to give it our buffer. We're going to give it an x. We're going to give it a y. And let's go a little bit further. Function v2. And we're also going to set the meta table, right? Set meta table. This needs to be a dot. Set meta table. Local out. Set meta table out. Cool. This is going to be interesting because we're going to have to do some different stuff with index eventually if we want to be clever, but we'll get there. Now we're going to write these in a better way, right? So we're going to go, you know, add something else to this vector. We're going to go m.add vec2. We're going to give it self. We're going to give it other. And there you go. That's all we need to do. Function v2 copy from. we're gonna do this differently, right? So in our C world, we're keeping the memory stuff very simple. We're passing in two vectors that have underlying buffers, and we can just copy between them very, very easily. In Lua, we're going to have a higher level view into this, right? So we're going to make a new vector, 0, 0. I mean, actually, we can go from .x, from .y eventually, but we can't quite do that yet. So we're going to make 0, 0, then we're going to call m dot copy vec to n from. Nice. You did recently fix some Blender import-export Python scripts. Nice. Yeah, nice. File paths, Windows, Linux. It's a classic. Tale as old as time. Nice. That's cool, yeah. And yeah, if you can fix us stuff for other people as well, that's really nice. So let's see how this runs. We might need a new test. Oh, unfortunately, my font renderer. I have an arbitrary font renderer, but I don't have it in this repo yet. So maybe we'll just go with something else. Let's copy our minimal example script. Let's copy it to cool. So we've got a minimal example script. M equals require math. Also, I don't know what I was doing before, but let's jump back in here. This isn't actually a require. This is just a constant. What did I call it? Math Lua. I called it math clib. Cool. So we jump in here. Jesse was nil. Is this ever used? I don't think we need this anymore, right? E.g. math. So if I've run this example, it should just work and show a black screen. Okay. It shows a black screen because there's an error. Math attempted to call nil value field buffer. Field buffer. Oh, hold on. Yeah, this isn't a up-to-date minimum viable example. Let's go back to a texture example. And we do need that GS variable. Okay. We need to do this. GS, cool. So what we're describing there really, oh, we've got TLB messes. That's not good. That's not good. Something's gone very sour. Something's gone very, very sour here. I have missed something. GS set output 440, 448. GS set output VRAM, mem, frame buffer, PSM. Why is this PSM 24? This should be PSM 32. And this is PSM 24. What has gone bad here? Maybe I need to... That's fine. GS. I wonder what's... Let's go back to main Lua. Let's go to our rectangle example, and that works. Okay, I don't know what happened there. Let's just... Cool. Okay, so we've got something, right? We've got something. Example math. Let's just get rid of this drawer. Can we run it? We get a nice blank screen. That's perfect. Local m equals require. Okay, so this is going to blow up. And this is probably actually going to blow up because we're saying this file returns something. So if we go to math, this doesn't actually return anything. So let's return v. I guess let's go out. V2. How should I name these? Let's maybe go lowercase. Vec2, Vec3. But actually, should these meta tables Vec4. Maybe we'll make meta tables and then say like out.vec2 is what's going to create it, and then we return types. We'll call this types. A bit of a janky name, but whatever. Okay. And not loving these names, but we'll survive. We'll see how this goes. If I run this again, it might actually work this time. And it does. It doesn't blow up on startup because there's no weird memory error now. That's wonderful. So now let's try and do some stuff with this. Math. Let's go before the frame starts. It doesn't really matter. V equals m.vec2. Let's go 5, 4. Now, one of the hard things about this, again, I realize, is we don't actually have any way to verify that this stuff happens. So let's just do some operations. Let's go v add, let's go local v2, v1, v2 equals m.vec2, 7, 7. Add v2, and let's see if this blows up when I run it. I attempted to call nil value field vec2. Function types.vec2. m.vec2, m is require math. This should be a valid function, right? Types dot m dot. This looks okay. Let's just try printing out some dumb stuff directly to the console. I do actually have a log function now, so I shouldn't do that, but whatever. Attempt to concatenate a nil value field empty. Vec2 empty. So somehow this has obtained a nil value, right? We return. Oh, hold on. I need to name this file something else. I don't know. Move script math. Lua already defines a math library that I believe this was getting overridden by. Yep. Let's do this. Now if I run, attempt to concatenate a nil value. Field MT. PS2 math. Let's go for KV in pairs, M, do. Let's print everything in this table and just see what happens. And then we can concatenate a table value, local v. How do we... Is it str? What's the Lua stringify function? Is it toString? Lua stringify table. There's got to be a way, right? I've done this before. Oh, well, I think the other thing I can actually do is that. And that should work. So it's got a vec2 underscore mt. It's got a vec2. Attempted to index a nil value global v. Line 31. v1. Okay, so now that I'm printing it out, it seems to be happier. Because of course, right? This is how it goes. Attempt to index a nil value local v1. So v1, when we create this thing, because we're not returning anything from this function. So set metatable returns the object you're setting the metatable on, so we can just return this function. Or we could return out, or we could collapse this down into like a one-liner. We go m.newvec2 buff x, y, and return it out like that. Isn't that nice? There we go. Now we have a few TLB misses, and this is concerning. You've been in a rut with console game modding. You've mastered audio texture modding, you managed to do it for several different games. Do you have to really make any 3D model level modding tools? It's really hard to do. It's really, really hard to do. I probably haven't just stuck to one game consistently enough. Yeah. It takes a long time to work out these data formats and stuff, you know, like, it's serious work. And then actually building a tool that can pull it apart and then reassemble it, it's hard. I was working on a random level generator for Super Mario Bros. 3 years ago. Like, probably, what year is it, 2022? Probably 4 or 5 years ago even. And I wrote tools that could take an individual level apart, change all the stuff in it, put it back together, you know, randomly generate the content for the level, then map a level map into game objects, because the game objects in Super Mario Bros. 3 are like really weird sizes. And it was really hard then to take a level you'd taken apart and put back together. You either had to work within the constraints of the original level sizes, or and I never quite got as far as completely taking apart the ROM, taking apart all of the tables that have the pointers to the levels, reassembling levels, you know, budgeting out size to different levels, and then putting it back together. I've got to, hold on. I'm going to allow myself to get sidetracked for a moment, because I know I have a video of this somewhere. If I can pull it up quickly, it might be very cool to show off. Because I don't talk about this project very often. I've never really shown this project off before. Store. Let me see if I very quickly have... Not that. Not that. Nah, maybe I don't have one on hand. Okay, I don't think I have, but this was a serious project, and it was very, very cool. Very, very cool. You'll have to take my word for it. And it worked. I could build some very simple random levels for the game. Anyway, that was a nice little break. Sincarius, thank you very much for the follow. Welcome to the family, and hopefully soon we're going to have a wonderful PlayStation 2 engine we can distribute to all of the people watching, and you guys can start hacking around and building some, for now, simple 2D games. We're going to get into 3D very soon. So, what is this TLB mess? Now that this is working, let's get rid of our really gross print. We don't need to print this stuff out. TLB mess. So we're trying to load something. We're trying to do stuff at address 0, right? A TLB miss basically just means we're dealing with a memory address that doesn't make sense, okay? It's like when you have a segmentation error on Linux. We just don't have an operating system to throw that kind of error on the PlayStation 2, so it goes straight down to like the more hardware level TLB miss. PCSX2 allows us to continue to run through TLB misses on real hardware that will crash your program every single time. Yeah, refraction. Address 0 means you're loading from null. Exactly. This is a null pointer exception by a different name. So let's go into here. And let's add a null check to our pointer. If pointer is null, then we want to log... Well, let's go Lua push string got null buffer for new vec2 Lua error. Cool. And this should be fine. And then we're going to do the same thing. Let's actually define a macro for this. Let's go define buffer null check. We're going to have a pointer, and we're just going to have a pointer. So what this is going to do Okay, because this is going to do something clever. I'm going to be clever. I can feel my brain like getting ready to have a good idea. Okay, I can feel it. Buffer null check. If let's actually do this properly, right? Do if not p. We wrap this in a do while 0. It's a C macro thing. If you haven't seen it before, don't worry. It's just what you do to stop things leaking out. If not p, then Lua push string. We're going to assume there's a variable called L in scope just because of what we know. Like we can make an assertion about how we're writing these functions. Lua push string cannot create, got null buffer for, and then we're going to use func. It's under func, right? We're going to use the name of the C function as part of this Lua error message. Lua error, go to a new line. Lua error L, return 1. Beautiful. So now instead of this, because we're going to have to do it a few times, right? We're going to have to do this all over the place. Buffer null check. We're going to go down. We're going to go down. The terrible style, okay? Don't write code like this, but also, you know, sometimes it gets the job done. And because this Lua stuff is so repetitive, there are some really cool spots where you can save yourself a lot of key presses by writing some clever macros. Okay. Expected something before func. Null buffer for. Oh, func. Can I do this? Can I do this? Not followed by macro parameter. I thought I could turn this into a string. Mad supervillain Quake player IQ, exactly. Am I a Quake player anymore? I haven't played Quake. I've played one game of Quake this year, I think. I played CPMA with someone. Little push string, got buffer for okay, let's forget this. Let's forget this. Or even better, let's just pass it in as a macro, as a thing, right? And actually, why isn't func a string? Why can't we just? Okay, well, let's do this for now. Sorry, I'm running it rather than. Buffer for. Why can't? What does func evaluate to? I thought func was the current function name. Func. Why? Hold on. C. How to use func in macros. Register func noun, use func name, blah blah blah, register wrap, struct out as func. So func is not a macro. Oh, func is not a macro. Func is not a macro. Huh. What the hell? I didn't know this. I thought this was a macro. Func is not a macro. Huh. So I'd have to sprintf it. So I'm not going to do that. So let's do this, right? But then we're going to go define null. No, that doesn't work, does it? We're just going to have to do it. Just going to have to do it ourselves. So, I don't know if this works. I guess it doesn't, right? Because this isn't, it can't concatenate it at macro time. Yeah, shit. Holy crap. Well, we're gonna have to name these ourselves. We're gonna have to say new vec2. We're gonna have to say new add vec2 argument 1. Copy vec2 argument 1, and then copy vec2 argument 2. Okay, we're going to build this, we're going to run this, it's going to give us some lovely null buffer for add vec1. Also, have I heard that someone's porting PS1 Tomb Raider to Game Boy Advance? Yeah, it's insane, right? They've written like a bunch of super nerdy ARM assembly to do 3D math. It looks really cool. It's amazing. If I had a Game Boy Advance, I'd try it out. I recommend anyone with a Game Boy Advance try it out. The frame rates aren't great. You know, they're acceptable, but it's just incredible that it runs at all. It's based on, I think it's called OpenLara, right? An open source reimplementation of the Tomb Raider engine. Okay, so we've got to look at math.lua, PS2 math.lua, sorry. Vec add, is it self? Is it this? I'm pretty sure it's called self, right? If I just look at like any other function, self, yeah, self. Addvec2 self other, m.addvec2. So is this whole argument nil? Is this whole argument nil? Let's go print, what am I doing? Print, let's go v2 add self other. I mean, it has to not be nil, right? v2 add, we've got 2 tables, but the pointer is nil. What if I go into where we do this alloc? Buffer Lua, buffer alloc, size head, it has a pointer, has an address as well, which is the pointer is a number that Lua can work with better. GameCube Game Boy player, that's cool. That's cool. GameCube, I respect a lot. I bought a Nintendo Wii because I wanted to play GameCube games, so I don't want to shell out for a GameCube. Self other. So let's print out the pointer field, right? Because this could actually just also be a typo. Let's not take that for granted. Let's not take that for granted. Both nil. Okay, well that's a problem. That's a problem. What about adder? Do these have addresses? They don't have addresses. They don't have anything. These are badly formed tables. m.new vec2 buff x y. Okay, we're gonna have to inspect this more carefully. We're gonna have to inspect this much more carefully. Much more carefully. So we've got this object. Let's print new vec2 o.pointer o.adder. I don't need to build, I can just rerun. New vec2, it has a table, it has nil pointer, nil adder. Why? Why? What happens to this new vec2? Yes, Lua new vec2 push string get table 1, right? Because we're allocing, we're making this thing buffer lua.c, right? This all gets set up and this gets returned. So oh, it only has a buff. It only has this buff field. Hold on. I've missed a layer of yeah, because we're storing the buffer in the vector, we're not like mirroring the structure of the buffer. The vector just has a reference to the buffer itself. So this should work now. Yeah, perfect. It says these things are nil, and they are indeed nil, right? They are indeed nil, but self.buff.adder and other.buff.adder, these things are not nil. Yeah, there we go. And this is just like spamming the heap, right? This is creating a lot of heap allocated objects. They're all very small, but it's not good. It's not good. This is not sustainable. All right, so math This is good. This is good. We need a way to actually get these fields. Sorry. So what if I could say, let's go log dot it's just log dot info, right? Let's go log dot info. Vector add result, and let's go v1 dot x. So how do we get this x field, right? Because if we look at the structure of this in C, got there in the end. This is just setting values in a C array, right? There's no structure here that lets us get back to this. And so I think we're going to have to come into our buffer and add something new, right? So if we go into ps2.buffer, push int, push float, we don't have good getters. We've got a read. What does read do? Buffer read. Returns an int, right? Returns an int at an index given by, and it returns an int at an index given by bytes, right? So it reads, So let's add 2 new APIs. Let's go int buffer get float. Let's just add get float for now. And this is going to be not indexed in bytes. We're not going to have to check if it's modulo 4. We're not going to have to divide it by 4. We're going to get the index divided by 4, right? So 0 is the first float. 1 is the second float. So in other words, byte index 0, byte index 4. We're going to do with one fewer thing, right? So like the second float in our vector in memory, right? So this is like x, this is y. We're going to call this 0 and 1, but internally this is actually like 4. This is 4 bytes into the structure. The old read API took this in bytes, but then relied on it being 4-byte aligned. It's going to be nicer for our Lua ergonomics if we do it this way. So int index equals Lua 2 integer L2 Lua push string what am I doing? Float pointer equals float. We'll explicitly cast this. Lua 2 user data. Index return Lua push number res, and then we return 1 because there's one thing left on top of the stack. Love it. Okay, put buffer read. We're going to add this in. We're going to call it get float. Hold on, what am I doing? That's set field. Lua push c func l buffer get float. I think that's what I called it. Lua, and that's it. That's all we do. Build. Jitspo, hey, welcome. Thank you for stopping by and checking out a bit of PlayStation 2 engine dev. Buffer get float. What did I call it? Float. What did I call it? Push float. We've had for a while. I did it as one word. That's fine. And let's have a look. I always try and scroll my mouse wheel for this, and you can't do it. Push number res, because we need to give our Lua state as well. Don't know what happened there. Where are we? And it looks like we're good. Of course, we still don't actually have fields for this yet. And Evan Tech, welcome as well. Thank you for stopping by. You guys passionate about weird console homebrew? I'm passionate about weird console homebrew. I love it. I love seeing people stop by and watch this stuff. It's not the most exciting stream today, right? We're building back up. It's been a slow ramp. It's been like a 4-month journey to get back to 3D math, and we're almost there. We're almost doing 3D rendering again. There's just some really important stuff to get right first. So we should be able to get a float. And let's see if we go into PS2 math. Okay, so Now this index function is gonna be a bit tricky, right? Because we need some other things in here. We need this to actually be a function because we need to evaluate code. So do we? How do we best do this? Ooh, Jitspo's raiding with a party of 29. Thank you so much for the raid. That is my second fat juicy raid for the night. I'm probably not going to be on too much longer, but I'm going to try and get a nice win out of the park here, do some cool Lua stuff, and then we'll see how we go. So let's make a function, okay? v2 index. This is going to take an object and it's going to take a key, right? So instead of giving a table as the index, we're actually going to give a function which does this lookup, v2 index. Yeah, PS2 dev's not something you see every day, never done it yourself. It's really hard. It's really rough. You get terrible error messages. You rely on emulators to like actually run things. It's really gross and it takes a lot of time and a lot of dedication to get things right. The hardware is really tricky, but hopefully building good Lua interfaces to things is going to make my life easier managing the hardware. That's my goal. You know, where I can use high-level constructs to express what I want to happen in the hardware and then let the nitty-gritty details happen under that. 150 Matteo, thank you very much for the follow. Welcome to the land of weird PS2 dev. Okay, so if k equals x, then we need to do something special. We need to say, we grab the buffer, okay? But do we need to raw get this? I think we need to use a Lua function called raw get. Yeah, let's do that. Buff equals raw get o buff. So we get a buffer, and then we say buffer get float 0. Right? So Lua is amazing because you can hack accesses like this. So now when we say, because of the structure, we're not quite done yet, but now when we say, v1.x, it's going to run this logic, right? If the key we're trying to access is x, then we do some raw data manipulation for our underlying data structures, and then we return it. I know what you're thinking, right? Isn't this horrifically inefficient? And the answer is yes. The answer is absolutely yes. But we're not going to do this very often, right? This is how we view at the end. So the idea is that we do a lot of our vector operations. We chain, these underlying functions that call C code and that eventually will potentially and, hopefully call optimized assembly for the PlayStation 2 that can, utilize some of the interesting hardware. But you pipeline these functions together, and then at the end of the pipeline, you kind of poke in and you say, hey, what's actually underlying this? And that can be slow, right? As long as we're not calling this for every add, for every subtract, whatever, we can afford to be slow a few places. Ifs and else ifs don't need ends. They do. They need an end here. Confusingly, and this is always something that throws me out, right? I always try and do it like this. I always try and go if blah 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 and else if blah 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 and. You don't need that. There's no end between if and else ifs and the final else. And yeah, I play Quake. I'm a Quake player. I've got a YouTube channel where I do Quake like esports analysis. I'm an Australian commentator. I'm a bit inactive at the moment, but I'm still interested in that. And yeah, the PlayStations up to the PlayStation 3 were very developer unfriendly for various reasons because they had odd hardware, very strange hardware, just to kind of get maximum performance to the dollar, I guess. The PlayStation 2 especially does an amazing job of this, right? Very simple components, the GPU is barely even a GPU. It doesn't do fragment shaders, but it has amazing vertex transformation capabilities, but you have to program those vertex transformations in a very arcane, very strange assembly format. Yeah, it's just a very unique system. But the PlayStation 3 is something else. But yeah, from the PlayStation 4, they kind of turned into standard x86, 64, PC-like boxes. And that was a deliberate thing to make everyone's life easier. Let's grab that spacer back. So, if I do this, what is going to happen? We're missing something as well. Else. And we need another else. Otherwise, we go types.vec2mtk. Otherwise, we just grab whatever is in our meta table. I didn't need to build that. And it looks like we've got that actually worked. So what am I actually doing here? I've forgotten what my example is, right? Math, 5 plus 7 and 4 plus 7. So 5 plus 7, that's 12. 4 plus 7, that's 11. I run this out and I get 12 and 11 printed out. That's pretty exciting. That's pretty exciting. Opti Ice Cream, welcome. Thank you very much. You made all your textures fit into the 8K texture cache, or you'll get cache misses. Yeah, exactly. Weird stuff like this that I will need to find out about as I go. I have done textured rendering. I have not done efficient textured rendering of anything more than a few, very simple examples. Am I doing vector sum? Yeah, I'm just adding up vectors now, but more importantly, I'm building a solid API where, I can do everything. Everything's just simple C arrays under the hood, but then I've got Lua views into that are nicer. So this works. I think I need to take this. I need to go offline. I need to spend some time, giving this some love and attention. Build this out for 3D vectors, for matrices, do rotation and stuff. I think I can do that off camera. That's not going to be particularly exciting. But this is a really fun, for me at least, I think this is a cool way of handling what will behind the scenes be very simple and very fast data just packed into a dumb array, but then also providing a high level view into it. This is kind of, the perfect representation of this whole product. So again, not a very PlayStation 2 specific stream, but one where we achieved some cool stuff. Yeah. Oh, hold on, no, this is fun as well, yeah. So almost all the textures were 64 by 64 4-bit palette to fit into the 8K cache. I have just done a few streams of building 4-bit texture palette support. So I've got like a custom tool which takes a targa and it compresses an 8-bit per pixel targa. It assumes, or it checks that all the indices are less than or equal to 16. It compresses it down into a hacked targa, an invalid targa that only has 4 bits per pixel. This is awesome. You always thought that this shit's trash, but it has some uses. Yeah, awesome. I'm glad to showcase some cool things. So, this has been a really interesting stream. I am going to pass the love on to another fine streamer here. I'm happy to take recommendations. I don't know that many programming streamers. I don't know how many of my people are online.